exam as well, or just CBSE?
Just CBSE, sir.
Okay, cool. And what are the chapters that you have covered till now?
In maths,
Yeah.
we have finished matrices, determinants, relation and function, continuity and differentiality, and integral.
Integral as well. Okay.
But it's before the vacation, only some we covered, only beginning.
Okay. So you have just started integration, right?
Yes, sir.
ठीक है. Let's wait for 2-3 minutes. तब तक कोई आता है तो, otherwise we will
Yes.
start the test.
Yes, sir.
So you must have been studying indefinite integration, है ना?
Sorry, sir.
Indefinite integration start हुआ होगा ना?
Yes, sir.
Okay. तो तुमने कुछ एक्सरसाइज की या फिनिश आपका कोई भी इंटीग्रेशन की?
No, sir.
एंड फातिमा, वन मोर क्वेश्चन जब तक अभी लोग आते हैं कि डू यू लाइक मैथ्स?
Sometimes.
No, you can honestly answer. ऐसी कोई बात नहीं. अच्छा, sometimes. So what is
Sometimes it feels hard.
so what is your favorite subject?
Biology.
Oh, you're an opposite gang. Okay. हाँ, हार्ड तो है ये तो बात सही है. बट कभी कभी हमने सही से पढ़ा भी नहीं होता तो उसके भी hard. मतलब कुछ तो हार्ड है ही. कुछ इसलिए बन जाती है क्योंकि हमने उसको उस पर्सपेक्टिव से नहीं देखा होता. That's what the teacher does, no? वो he or she will try to make that thing simpler for you.
Yes, sir.
I don't think anyone is coming. कोई आता है तो देखते हैं फिर. चलो, क्या तुम्हें डिफरेंशिएशन समझ आया था? तो ये बताओ.
Sorry, sir.
क्या तुम्हें डिफरेंशिएशन समझ आया था?
No, sir. Like I need from beginning. Only she started the introduction.
चलो, मैं तुम्हें बहुत बेसिक. पहले मैं तुम्हें आज बहुत ज्यादा तुम इंटीग्रेशन के बारे में कुछ नहीं जानने वाले. मतलब कैसे हम इंटीग्रेशन कर सकते हैं, पर हाँ तुम ये जानने वाले कि इंटीग्रेशन क्या होता है, कैसे, मतलब हाउ डू वी विजुअलाइज इंटीग्रेशन. ये तुम्हें मैं आज समझाने वाला हूँ कि क्या कर रहा होता है इंटीग्रेशन एक्चुअली. एंड आई
Okay,
ऑल्सो
sir.
बिलीव या एंड आई ऑल्सो बिलीव कि अगर हम विजुअलाइज करके देखना शुरू कर देते हैं ना फातिमा चीजों को, तो इट बिकम्स इजियर, मच सिंपलर, और हम मेमोराइज भी कर सकते हैं वो चीजें। अगर हम देख लेते हैं एक बार के, विजुअल इम्पैक्ट ज्यादा होता है एज कम्पेयर टू कि हम किसी चीज को बस रटते रहें और करते रहें। तो इसीलिए मैं इंटीग्रेशन के बारे में पहले तुम्हें कुछ बात बताना चाहूंगा कि एक तो बेसिक बात कि जो हमारा पूरा 12th क्लास का सिलेबस है ना, देख स्टार्ट कर ले, मैट्रिसेस डिटर्मिनेंट हटा दे। मैट्रिसेस डिटर्मिनेंट के बाद जो नेक्स्ट 4 चैप्टर्स हैं, ये तेरा होगा रिलेशन एंड फंक्शन, ITF इनवर्स ट्रिग्नोमेट्रिक फंक्शन, देन कंटिन्यूटी एंड डिफरेंशिएबिलिटी, एंड देन एप्लीकेशन ऑफ डेरिवेटिव्स। ये चारों चैप्टर्स कैलकुलस के अंदर आते हैं। ठीक है। सिमिलरली जो अभी 3 चैप्टर्स तुम पढ़ने वाले हो, इंटीग्रेशन, या फिर इसके बाद आएगा एरिया बाउंडेड बाय कर्व्स, और लास्ट आएगा डिफरेंशियल इक्वेशंस। ये अभी 3 चैप्टर्स आएंगे, ये तीनों इंटीग्रल कैलकुलस का पार्ट। तो लेट मी क्लियर दिस। 2 पोर्शन हुए हमारे पास। कैलकुलस इज डिवाइडेड इनटू 2 पार्ट्स। फर्स्ट पार्ट इज डिफरेंशियल कैलकुलस।
Okay, sir.
Differential calculus basically includes everything that consists of differentiation. यहाँ पे आपको सारा का सारा डिफरेंशिएशन से रिलेटेड चीजें मिलती रही। तो एक पार्ट होगा इंटीग्रल कैलकुलस। इसके अंदर 2 चैप्टर थे जो आप पढ़ चुके हो। अगर आपको कभी आगे चल के इसमें परेशानी आती है, आपको लगता है कि नहीं मेरे को नहीं आता ये चैप्टर अच्छे से, तो आप मेरे को बाद में बता सकते हो, मैं आपको ये बता दूंगा तब जब कंप्लीट हो जाएगा अपना ये इधर वाला सिलेबस। और दूसरा चैप्टर था यहाँ पे एप्लीकेशन ऑफ डेरिवेटिव्स, AOD बोल सकते हैं इसमें, श्योर।
Okay, sir.
वैसे अगर मैं इंटीग्रल कैलकुलस के बारे में बात करूं तो इसके अंदर 3 चैप्टर्स आ रहे होंगे बच्चे। पहला इंटीग्रेशन। Integration in itself is divided into 2 parts. First part is indefinite integration, and second part is definite integration.
Okay, sir.
फिर सेकंड चैप्टर जो हमारा होगा वो होगा एरिया बाउंडेड बाय कर्व्स, एंड लास्ट चैप्टर जो बच्चे हमारा होगा वो होगा डिफरेंशियल इक्वेशन। अगर हमारा इंटीग्रेशन अच्छा होगा तो हमारे दोनों अगले वाले चैप्टर्स भी अच्छे हो जाएंगे,
Okay,
क्योंकि
sir.
यहाँ पे इंटीग्रेशन के फॉर्मूले ही सीधा सीधा उठा के देखिए यूज कर रहे होंगे। तो हमें यहाँ पे कुछ फॉर्मूले याद होंगे तो हम ये नेक्स्ट दो जो चैप्टर्स हैं उनको भी बहुत इजीली कवर अप कर सकते हैं। और ये पूरा का पूरा पोर्शन इसीलिए इंटीग्रल कैलकुलस बोला जाता है, क्योंकि तीनों चैप्टर्स के अंदर इंटीग्रेशन यूज होगा। जैसे वहां पे अगर तुझे याद हो तो एप्लीकेशन ऑफ डेरिवेटिव्स के अंदर भी हम लोग डिफरेंशिएशन करे जा रहे थे, बार बार डिफरेंशिएशन
Yes,
निकाला करते थे। मैक्सिमम मिनिमा निकालने के लिए भी हम डिफरेंशिएशन नहीं निकालते थे। तो वही सारी चीजें बिल्कुल जैसे वहां पे बार बार डिफरेंशिएशन यूज होता था, वैसे सिमिलरली यहाँ पे इंटीग्रेशन यूज होता रहेगा। और अभी मैंने तुझसे ये भी बोला था कि देख फंक्शंस और ITF जो चैप्टर है ये भी कैलकुलस के अंदर ही आते हैं। अब मैं तेरे को एक बार ओवरव्यू देता हूँ। तो कैलकुलस कहाँ से स्टार्ट होता है? कैलकुलस क्या कहता है? कैलकुलस कहता है देखिए थी एक चीज होती है फंक्शन, ठीक है। अब फंक्शन क्या है
okay,
मैं तुझे बहुत ही डिटेल से ऐसे छोटा छोटी बातें बता देता हूँ। फंक्शन यार ये है कि तूने वॉशिंग मशीन में कपड़े डाले और उसने धुल के तेरे को, गंदे कपड़े डाले उसने साफ कपड़े करके दे दिए, ये एक फंक्शन हो रहा है।
yes, sir.
लेट्स से तूने मतलब कोई भी चीज एक फंक्शन है। तूने अभी अभी मैं देख टैब पे लिख रहा हूँ तो वो मेरे, मैं यहां से लिख रहा हूँ वो तेरे को स्क्रीन पे दिखा दे रहा है। तो
Yes,
बेसिकली कोई कोई भी एक इलेक्ट्रॉनिक डिवाइस ले ले और देख वो कैसे वर्क कर रही है। लेट्स से फोन तूने टच किया, उसने तेरे को रिजल्ट दिखा दिया कुछ।
yes,
अगर तू इसको जेनरिक सेंस में समझे, जनरल सेंस में समझे, तो क्या मतलब है इस बात का? एनीथिंग इज अ फंक्शन विच कंटेन्स 2 थिंग्स, फर्स्ट इनपुट एंड सेकंड आउटपुट है। आप कुछ इनपुट देंगे, आपको कुछ आउटपुट मिलेगा, इस चीज को फंक्शन बोल देते हैं। ये बहुत ही एक हमारी जस्ट hello Abdullah, am I audible?
Hello, sir. Is this math class 12?
Class 12, yes.
Okay,
Maths
fine.
class.
Yeah.
So I have 2-3 questions for you first. From where do you belong?
From where? What?
From where do you belong?
From Yemen.
Yemen. Okay.
Yeah.
And what your syllabus is CBSE, right?
Yeah, CBSE.
Okay. And what are your subjects?
My subjects?
Other than maths? Yeah, other than maths.
Science. Science. And
Science.
English,
Means physics,
English,
chemistry.
science. Yeah.
Okay. Physics, chemistry, bio, and English, right?
Physics, chemistry, bio, English, yeah.
And are you also, are you also appearing for any competitive exams other than CBSE?
No. Only CBSE and finished.
And what do you want to do after 12? Have you anything
Well,
in mind?
I don't know until now. I don't know. There is nothing in my mind.
Okay. What about you, Fatima? What are you thinking after 12? Have you thought about something?
Yes, for doctorate.
Okay. ठीक है, तो Abdullah, I was giving this overview about 12th class first of all. Okay, 12th कैसे proceed करते हैं? Are you comfortable in Hindi?
No, sir. I don't know any Hindi.
ठीक है. Yeah. Okay. So I was giving you an overview about 12th class syllabus. First of all, what does 12th class? First of all, the major portion of 12th syllabus contains this unit calculus.
Yeah.
This is considered a very dreaded word, though, calculus, because it's the hardest portion of maths. You can say that. So calculus is contains the major portion of 12th class, which is around 50%. Right? And what does calculus include is there are three parts, there are three subparts of calculus. First part is functions and inverse trigonometric functions. So first part is basically all about functions, which you have already studied, I guess. Abdullah, is that true? You have also studied functions, right?
I don't remember actually because we had now a holiday. I didn't revise, and I'm not that good in math.
Okay, you don't like maths?
Half.
Half. What is your favorite subject?
I don't have a favorite subject.
You don't like to study?
I don't like to study.
Okay. Then what's your favorite thing? What do you like? What are your hobbies? What do you like?
Nothing.
Nothing?
Yeah, nothing.
There has to be something, no? Sports. Find your hobby.
Football, maybe. Only football. But not every time.
Yeah, I know. I get that. You can't study every time as well. You can't study for full time as well. You can't do anything for all the time.
Yes.
Okay. So you have to pass, right? So I'll make you that comfortable in maths that you can easily get 40, 50 or above percentage of marks. Yeah. That's my goal. So I was basically giving you an overview about calculus. So calculus consists our major portion in 12th class. Calculus is subdivided into three parts. First is function. So first of all, I want you to understand what is a function. So every electronic device is a function, like washing machine. I'll give that machine some dirty clothes, and what does it give me back? Have you used?
It gives clean clothes.
Exactly. So it will give us clean clothes. So we will giving that thing an input which is dirty clothes, and we are in return getting the output as clean clothes. Same is for phone, any smartphone. We will touch the screen, we'll give some input, and we'll get the output. Let's say I want to search something on Google, right? So I'll write, and it will give me when I'll press search key, it will give me back the results related to that thing, right? So the process is that we will give it some input and we'll get back some output. So anything that can follow this rule, that if getting some input, that thing can provide us some output, that thing is called a function. So all the electronic devices are considered as a function. In maths, there will be a relationship between x and y, which will tell you what the function is. For example, y is equals to x square is a function that consists two things, x and y, where x is considered as input. X is basically input and y is basically output. This is the very simple notation and the most popular notation used in function, that x is always an input and y is always an output. Now, if I give it input as 1 or 2, let's say 2. So I put x is equals to 2, I get y is equals to 4. So on providing input as 2, I'll get the output as 4. Similarly, if I give it an input 10, what will be the output? 100, right? So on and so forth, whatever you want to identify. So you will give an input and you will get in return an output, right? So that thing is function. Not going into the much technicalities of a function right now, because we have already studied function. But if you face any problem, you can ask me in the later classes, later on. Now let's come to differential calculus and integral calculus. So what does differential calculus and integral calculus do is, they perform some operations on a function, right? On one function or two functions or many functions. So they will all perform some operations on functions. Now, what are these operations? So differentiation is the operation of differentiation basically breaks down anything into small pieces. So differentiation is breaking down something into smaller quantities. Listen to me very carefully. Differentiation is basically breaking down anything to simpler or smaller quantities. While integration is just the opposite of differentiation. What does integration do is, it will collect all the smaller pieces and will form a bigger piece, a bigger thing. So for example, if I have this object, I want to differentiate it. What does it mean is, I want to make smaller pieces of it, just like that. How many pieces? Infinite. I want to break it into the smallest piece that is possible. And if I want to integrate something, so integration is basically, if I have these small infinite pieces, I can add them to form this greater rectangular sheet, this complete sheet, just like. So this process is called integration. Yeah, Fatima, if you want to ask anything, please.
So, please explain it again. I was having some issues.
I think your voice is not audible. Please say it again.
Sir, can you please explain again? Because I was having some issues.
Yeah, sure. So what does differentiation do is, differentiation breaks down a bigger thing into some smaller pieces, right? Like I have this, if I have this rectangular sheet, this 1, I'm denoting this as 1. So if I have this rectangular sheet as 1, this is a piece of paper, let's say. And if I break this down into these smaller pieces, This is second. So if I perform an operation from 1 to 2, that is, I am basically dividing a piece of paper into very small quantities of papers. So that is basically the breaking down of a bigger thing into smaller pieces. That is differentiation. But if I do the opposite, that is, I have been provided with the smallest things possible. And if I collect all of them and make a bigger thing, that is something known as integration. So that is the basic phenomena of integration and differentiation. Differentiation breaks down a bigger thing into smaller pieces, while integration collect all the smaller pieces to make a bigger thing. Is that correct, Fatima?
Yes, sir.
So the process from going from 2 to 1, is integration. But from 1 to 2 is differentiation.
Okay,
Is that correct?
yes, sir.
So first of all, integration and differentiation are the opposite of each other. That is why I asked you, Fatima, that did you understand that differentiation?
Yes, sir.
If you understood differentiation, then you will be facing less problems in integration. But definitely integration is tougher than differentiation, first of all. Okay, can I raise this?
Yes, sir.
What about Abdullah? Can I raise this? If you are writing, so you can raise your hand. Just raise your hand. Till that time you write it. You don't need to say no or yes. And if you are not writing, then stay quiet. I'll get it. Now let's talk about integration in detail. So we have understood the basic nature of integration. What does integration do is summation. That is to add. It adds all the things. To add objects to make a bigger object. That is the basic rule of integration. Now, there are two types of integration. First is indefinite, and second is definite integration. We'll talk about definite integration later on. Let's talk about indefinite integration. Okay, the first part we have to study is indefinite integration. Now, to understand indefinite integration better, we need to know about the differentiation first. So you have to tell me these small differentiations. I'm asking you some questions. What is the differentiation of x squared? How do you identify the differentiation of x squared? And how do you calculate this?
X square's differentiation is x.
Is x squared differentiation is 2x or x.
It's 2x.
It's 2x, right? So we differentiate by taking power with the multiplication. We take the power in multiplication and we reduce power by 1. So
Yes.
this is the basic principle of differentiation. Similarly, the principle of integration is just opposite of it. So if you differentiate x square, you will get 2x. But if you integrate 2x, so This is the sign of integration, first of all. This is integration. So if you integrate 2x and you have to integrate something with respect to something, just like you differentiated something with respect to something. So if you were differentiating x square, you differentiated it with respect to x. This was read as d of x square, that is differentiation of x square with respect to this d. This d means with respect to x. Similarly, if you want to integrate a function, you will have to put this symbol, which tells you which is a symbol of integration, as well as you have to integrate with respect to some variable with respect to x. So what does this expression in whole means is that you are integrating 2x with respect to x. So integration of 2x dx. Right? Integration of 2x will be x squared. Just the opposite process of differentiation. Did you guys get it? I'll tell you the whole principle as well, but just for this. Yeah, please. If you want to ask anything, Fatima, you can ask.
Sir, can you explain again?
Yes. So what I'm telling is, if you know the differentiation of a function, right, and you reverse the process, that is, you know that the differentiation of x squared is 2x. So the opposite of this, the reverse process of this is, if you integrate, what does x differentiation of x square means? The smaller parts of x square, when you break down x square. But if you collect all those pieces, so you can again make x square. How? By integrating. So if the differentiation of x square is 2x, similarly, the integration of 2x is x square. That is the opposite reverse process of differentiation.
Yes, sir, I understand. Thank you, sir.
So, yeah. So integration of 2x with respect to x. This means this mathematical expression identifies this. Integration of 2x with respect to x is x squared. Okay, let's now understand the basic principle. Let's take one more example. So, do you know the differentiation of sin x? Differentiation of sin x.
Sine square x.
Cos x. Differentiation of sin x is cos x. So can you identify the relationship in terms of integration? If the differentiation of sin x is cos x, then the integration of what?
Integration of cos x will
Should
be sin x.
Yes, got it. You will go get a formula. Integration of cos x is sin x. Okay, one more interesting. You know the integration of x square is 2x, right?
Yes, sir.
We have already done that. So let's tell me integration of x square plus 5. What is the integration of x square plus 5? So we'll first integrate x square, which is 2x. Then plus, then we will integrate 5. Oh, sorry, differentiate 5. What is the differentiation of 5? 5 is a constant. What is the differentiation of 5? Fatima? 0. Differentiation of any constant is 0. So the differentiation of x square plus 5 is also 2x. Am I correct?
Yes, sir.
So the integration of 2x can be x square plus 5 as well. By using the same relationship which we were using before, integration of 2x can be x square plus 5, right?
Yes, sir.
And in the recent example which we have done, we have already done x square. The differentiation of x square is 2x, and the integration of 2x is x square. But right now, what I am saying is that the integration of 2x can also be x square plus 5 using this example. Now, there induces a confusion right there. But what should be the integration of 2x, right?
Yes.
So why this is, I wanted to actually make you understand the concept of indefinite integration. So indefinite is something which is not confirmed, which we don't know exactly, right? So indefinite integration says that whenever you are integrating any function, you will have to put a c, which is constant of integration, which can contain any constant, because the differentiation of any constant is 0. So while integrating 2x, the correct expression should be x square plus c, where what does this c signifies is constant of integration. This is some constant value only, because what we are saying is that x square plus any constant, its differentiation will always be 2x. It doesn't matter if there is a constant with x square in addition or subtraction, but the x square plus c will always yield a differentiation equal to 2x. So while integrating 2x, we will get x square plus constant, because this constant has no value in terms of differentiation. When we differentiate a constant, we get 0. So x square plus any constant will always yield the differentiation 2x. Hence, the integration of 2x should be x square plus constant of integration. That is why what we do is, when we do indefinite integration, we always put this c in the answer, because this c signifies that we can also have any constant, because that doesn't change the differentiation of sin x plus c is also cos x. So integration of cos x should be sin x plus. Did you understand this?
Yes, sir.
And whenever the c removes, now how does that happen? We will talk that in definite integration. But if we can remove this c, that will be definite integration. So in that case, we will know the exact value of differentiation. Right now, we don't know the exact differentiation. We know the function, but we don't know this constant term. So this changes to a rule, that is how we do indefinite integration. Can I erase this?
Yes, sir.
Have you written all of these examples? These are important for your understanding.
Yes, sir. I have written.
Okay. So if you know a function is fx, and you know the differentiation of this function with respect to x is some other function gx, right? Then you can multiply this dx on that side. So you can also write this. I'm telling you the intermediate steps which are happening in differentiation and integration. You can multiply that dx into right hand side and you can write it as this. Then you can integrate both sides. Integrating both sides. So if you know the integration of a function fx is gx, if you know the differentiation of a function fx is gx, then the integration of gx is fx. But how do you know that? I am proving this. Integrating both sides. Integrating both sides means applying this sign.
Yes, sir.
So integration of d of fx is equals to integration of gx dx. Now, this integration into d, this thing is 1 because they are reverse process of each other. Reverse process of each other means that integration is equals to 1 upon d. But just d, Fatima, remember this, not dx. Integration is not equal to 1 upon dx. No. You can't say that this integration and this dx also multiplies and gets 1. You will get 1. No. Integration into d. If you have only d, then you can integration into d is 1. But if you have integration into dx, integration into dy, no, not 1.
Okay, sir.
So integration is equals to 1 upon d, or d, yani ke derivative, is 1 upon integration. You can use any of it. So this is 1. So what happens is it becomes fx in the left hand side, and the right hand side has become gx dx, integration of gx. So the basic concept is, if the differentiation of fx is gx, then the integration of gx is fx. But let me tell you another thing. What is the concept of indefinite integration? So if I take fx plus c, means any constant, then its differentiation will not change. It will also be gx only, because you know the differentiation of fx is gx, and you know the differentiation of a constant is 0. So it will be gx plus 0, but that doesn't change the value. It is gx only. So what we can say is that while calculating the integration of gx dx, I should have already put fx plus c. Just explaining the concept. Why are we putting this? This c is known as constant of integration. As long as you are solving indefinite integration, you will be including constant of integration in every answer. This is the basic concept of integration. So if you are good at differentiation, you will be good. You'll be okay in integration as well. Can I remove this?
Excuse me, sir.
You can just raise the hand if you like.
Sir, can you please explain after integrating both sides?
Yeah. Yes. So after integrating both sides, what we have written is, this is integration of d into fx, and this is integration of gx dx. See, it will look like this. Am I right? If we integrate both sides, we'll put the sign. Yeah. Okay. So what does this become is integration into d. So I was saying that if we get integration into d, only integration, the symbol of integration into D, then it will become 1. Because there is a relationship between integration and differentiation, that they are the reverse process of each other, which I have written here as well. You can write integration is equals to 1 upon D. So if you shift D from right hand side to left hand side, it will only become whatever I have written here in this star, that integration into D is equals to 1. And the right hand side will be same, because integration into dx is not 1. No, I'm not saying that integration into dx is equals to 1. No, this is not true. Integration into dx is not equal to 1. But if I write integration into d, it will always be equal to 1. So the left hand side, we get one integration symbol, we get 1d. We multiply them, we get 1. Whatever the left is, that is fx, is the left hand side. And in the right hand side, we can't do anything, because we don't have integration into d. So we will write it as it is. And it means that if the differentiation of fx is gx, then the integration of gx is back to fx.
Yes, sir.
So if you are writing, you can raise your hand. Was that it is?
I have written, sir.
Now let's come to formulae. Because without formulae, we will not be able to proceed integration. These are some basic formulae. First is, I'll give you some questions, then I'll make the form so that you understand better how are these formulae coming. So if I differentiate this is a simple function, Fatima. This is x
Yes,
to
sir.
the power n plus 1. N is any number.
Yes.
So this is x to the power n plus 1. For example, if n is 4, then this is nothing but x to the power 5.
Yes.
If n is 10, what is the function?
X to the power 11.
5. So I am asking you, what is the differentiation of x to the power n plus 1? You know the rule of power. No worries. You take your time. Just tell me this. Yes. So what is the rule of power? If you have to differentiate x to the power 3, how would you differentiate it, Bachit? D of x cubed divided by dx. How would you do that? Okay, so you take the power in the multiplication. Here power is 3. So you take 3 in multiplication and you reduce power by 1. So 3 into x square. Is it okay?
Yes.
So what is the differentiation of x to the power 5?
It will be 5 into x raised to 4.
5. So what should be the integration of this? Here, what is the power? What is the power here?
It is n plus 1.
N plus 1. So n plus 1 should be in multiplication and we have to reduce power by 1. What would that be? N plus 1 minus 1 would be n, right?
Yes, sir.
It should be n. So while differentiating x to the power n plus 1, the answer should be n plus 1 into x to the power n. Correct.
Yes, sir.
So if I integrate n plus 1 into x to the power n, then the answer should be x to the power n plus 1 plus c.
Yes.
Because I have only reversed the process. Now just divide the whole expression by n plus 1. It would become, because n plus 1 is constant. N plus 1 is a constant value. I can do anything with a constant, not with the variables, but with the constants. I can divide this, I can add this, add any constant, or subtract any constant from both sides, or multiply the both sides by any constant. So I can do anything with a constant, but not with the variables. So I am dividing the whole expression by n plus 1. So what would this become is, this would become x to the power n dx, because n plus 1 will cut out and cancel out. And here, x to the power n plus 1 divided by n plus 1. This is a constant divided by another constant n plus 1. So I am naming this constant as C1. C. I mean, check this. This is a constant, right? C1 will be any constant only.
Yes, sir.
N plus 1 will be a constant only.
Yes.
So can I say this whole thing is a constant only? Can be anything, but it has to be a constant only. Am I correct?
Yes, sir.
If I am dividing 10 by 2, I will get 5, not something in x, right? If I divide 100 by 5, I'll get any constant. Yeah, so that's what I'm saying. If I divide a constant C1 by another constant n plus 1, I'll get a constant only, which I'm naming as C. So the first formula is, if you take x to the power n dx, and the rule of power works here like this, that you have to increase power by 1 and you have to divide the whole expression by that power only. Which means, let's use it in an example. If I am integrating x squared dx, then the integration should be x to the power, whatever the power was given, you have to increase it by 1, that is 3. You have to divide the expression by the same number. Did you get it?
Yes, sir. Yes, sir.
Can you tell me the integration of this x to the power 10?
It will become x raised to 11 divided by 11 plus 3.
Can you tell me this integration of, it's okay. First write this. Then we'll talk. Next question. Is it done?
Yes, sir.
Okay, so this was the first formula. The second formula is the integration of any constant. Let's say K. K is any constant value. K belongs to real number. So if I integrate something constant, I can take that constant out of the integration sign like this. So what here would become is 1. Can I write it like that? K into 1 is K. Like 4 into 1 is 4.
Sorry, sir.
Can I write this K? If I was saying that if I'm integrating any constant, so I can take that constant out of the integration sign. For example, if I'm integrating 4 dx, so I can write 4 as 4 into 1. Right?
Yes, sir.
So I can also write this as this. 4 into 1. You can write 4 as 4 into 1. Take 4 out and leave dx with 1. Can we do this?
No.
We can certainly do this. We can take any constant out of the integration symbol. That is a property of integration.
Okay, sir.
So we can take this K out of the integration sign. And what we are left with is 1.
1.
We can write 1 as x to the power 0. Anything to the power 0 is 1, right?
Yes, sir.
So we can write this 1 as x to the power 0. Now we know the rule of 0. We know the rule of power. How does that work? X to the power 0, the integration of x to the power 0 should be increase the power by 1 and divide the function by the same power.
Yes,
So
sir.
it should be
X raised to the power 1 divided by 1.
plus c. If you divide anything by 1, so it will be the same thing. 4 by 1 is 4. Right?
Yes, sir.
Okay. So the integration of k into dx is kx. What does it mean is that integration of 4 into dx is 4x plus. So can you tell me the integration of 11 dx? 11 into dx.
11 integral 1 into dx.
Okay. Correct. Sorry. Correct. Then you can write 1 as x to the power 0. No. Just like that. Take this k as 11. The only difference is k is 11 here.
Yes, sir. Yes.
When you take 11 into x to the power 0 into dx, then the integration of x to the power 0 is x. So we can directly write it. 11x plus c.
11x plus c. Yes.
Okay, do this. Sorry. 10x plus 5 into dx. So Fatima, whenever some functions are in addition or subtraction, we can distribute the integration of both of them. We can integrate 10x first, then we can integrate 5 later on. So what we will do is, we can write this as, we will multiply dx with both of them. We know the distributive property. This will become 10x dx plus integration of 5 dx. We know the integration of 5 dx. We have just solved this. Tell me, what is it?
So your voice is lagging.
Acha. I'm asking you, you know the integration of 5 dx, right? Can you help me with that? What is the integration of 5 dx? What is the
You mean the
integration
power?
of any constant? Oh, yeah. What was the integration of 4? In the first example, what was the integration of 4?
It was 4 into 1.
Integration was 4x. This was the
So it will be 5x.
4 into x. Integration of 4 was 4x and c was added so that we can compensate if any constant comes. Am I audible now, Fatih?
So it will be 5x.
Will be 5x. Very good. And the integration of 10x, for the integration of 10x, you can take the 10 out of this integration sign, and now you can integrate x into dx. You know the rule. What should be the integration of x into dx? What should be the integration of x dx?
It is x raised to 0.
Why 0? We have to increase the power by 1. Right now we have power of x as 1, and we have to increase the power by 1. So what should it be?
It is x squared.
X square? Only x square or anything else?
X squared divided by
Yes.
2
Correct.
plus c.
Plus c. So let's say it's, so what we can do is, if we are integrating two different things, use only once. That will manage. So it will become something like this. 10 into x square by 2. You can cancel out 10 with the help of 2 as, so this will become as 5x square plus 5x plus c.
Plus c.
Did you understand this, Fatima?
Yes, sir.
So we'll study later on now. The class timing is over for today.
Thank you, sir.
Welcome.